Welcome back to the Xplore YouTube channel. So in this video, we are going to focus on linked lists in Java. So the previous section, we have covered arrays. Now we all know what an array is. Now with respect to linked lists, let's see how it's kind of different with respect to arrays. Now in arrays, we remember that the elements were stored in a very precise format, which was contiguous memory location, right? This is some term which we kind of understood from the array explanations. Now, what do I mean by contiguous memory allocation? So let's say in the array, we are storing integers. So let's say the very first integer is 5, then the next integer is 9, then followed by 10, and then so on. So let's assume that, let's say 5 is stored at the location x, then 9 will be stored at nothing but x plus 4. 10 will be stored at nothing but x plus 8. Now, why am I incrementing 4 here? I added a plus 4 here. Then again, I added a plus 4 here. Why is this happening? Because we all know that the integer is going to occupy maybe like a 4 bytes of space, right? So I hope that kind of clears your doubt that, okay, why am I increasing it by 4? And also, since array, as I have explained, it's contiguous memory allocation. So if I want to access this element 10, then I can start maybe from 5 and then continuously go element wise element and then access the value 10, right? Now, how is linked list different with respect to arrays? Well, in linked list, the beauty of linked list is that the elements are stored not in a contiguous memory format, right? But more of in a scattered way, right? More of in a scattered way. So let's say I need to have 5, 7, and 9 as few of the elements inside of my linked list. Then one of the most precise ways is that, okay, 5 is going to be stored in some block representation, which we generally refer to as node. Yes. And then we'll be having something like a 7. Then we'll be having something like a 9, right? But the real thing is that, okay, let's say 5 is at a memory location X. 7 might be at a memory location Y, right? It's not necessary that 7 will be at X plus 4 on itself, right? It can be at a memory location Y. 9 could be at a memory location Z, right? And then so on, and then so on. Now, the thing is that how do I move from 5 to 7 and then 7 to 9 in a very precise format one by one? Well, we kind of move internally. This is how it is represented. So from 5 to 7 there is a linkage, right? That's what I'll call it. There's a linkage. 7 to 9 there is indeed a linkage. By the way, a very important thing which you have to remember with respect to interviews: linked lists in Java has an internal representation of doubly linked lists. Yes, doubly linked lists. Now, what is a doubly linked list? Well, the basic representation of a doubly linked list is as follows. So this is what the node block of a doubly linked list looks like. So there are 3 parameters here. Yes, there are 3 parameters. The very first and the last parameter is a pointer. Yes, so this is something we call as previous pointer. This is something we call as next pointer. So the previous pointer, as the name says, it points to the previous node. The next pointer points to the next node. And what is this field? This field is very important. This is the data field. Let's say the data could be 100, right? Now, what is this next pointer going to point to? It's going to point to one more, node block, right? This is node block 1. This is node block 2. Node block 2. NB stands for node block 2. Okay. So again, here I'll be having something like previous, some value, let's say 101, and then we'll be having next. Again, this next will be pointing to something, right? Something. Now the thing is, what is this previous doing? Notice carefully. This previous is going to point to this node block. So you get the point that from this node block 1, I can go to node block 2 with the help of next pointer. But from node block 2, can I go to node block 1? Yes, I can, with the help of previous pointer. So this is what the internal representation or implementation of a linked list in Java looks like. Right now, you don't need to know about the next and the previous pointers. This is really helpful or really important. It's helpful, but it's really important with respect to interviews as well. So right now I know that, okay, hey, if I want to go from 5 to 7, I can go in this fashion, right? So this is what the internal representation looks like. Again, this is something for your own understanding, so it's beneficial, right? So this was a little introduction to what a linked list in Java has to offer to you, right? Now, when to use it, right? When to use it? Because I know for a fact I can represent 5, 7, and 9 in the format of a simple array, right? Then why do I need the usage of linked list, right? Now the thing here is linked list is nothing but a dynamic array. Yes, this is the very first thing you will ask if someone comes up to you and tells you, hey, how is linked list different from an array? Or hey, when do I need to use linked list? This is what your answer should be. Hey, linked list is kind of like a dynamic array in which dynamic memory allocation happens. Yes, dynamic memory allocation happens. So what happened in array actually? If you remember, in array, if I had some few elements, 5, 7 and 9, and let's say I want to add something like 10, right? Then in that case, I cannot simply add 10 right here, right, in this fashion. No, it's not possible in case of arrays. What I need to do is I need to create an array of size 4. Once the array is of size 4 is created, I will copy 5, 7 and 9 to their respective positions, and then I'll copy this element 10 to this last position. So you can see there's a very big process, right? This is a very big process, right? So from this array you created one more array, and then you copied these 3 elements here, and then you copied the very new element to the last position. So I think so there's probably 3 to 4 steps here. But what about linked list? Yes, what about linked list? So let's say I want to add an element 10 here, which is again represented in the format of a node block. Well, we can just simply have 10 here, which is at a memory location, let's say A, and then so on. The next elements can be added, right? So in this case, I see linked list can be used when our use case is, yes, when our use case is that there is a lot of manipulations on the data. Use cases, there is a lot of use cases. There is a lot of, or I can say there is frequent manipulations here. There is frequent manipulation of data. Yes, frequent manipulation of data. Indeed, with respect to linked lists as well, it's really beneficial when I need to delete a node, right? How can I say that confidently? So let's say this is what the linked list looks like right now, right? And let's say I wanted to represent the same thing in the format of an array as well, right? Now what will happen? Let's say I want to, let's for a safety purpose, let's have the element 10 here as well. Okay, now let's say I want to remove 8, or let's say I want to delete the value 8. What's the process? Let's see what's the process in array. Well, I can't just simply remove 8. Well, I can just say that, okay, hey, I removed the value 8 and I'll assign this a value, let's say 0, which says there's no value. But again, 0 is a value in itself, right? So how do I figure out that, hey, at this place the value has been removed or not? How do I figure that out? Well, in array the process is as follows. To remove 8, what I'll have to do is I'll have to create an array of size 1, 2, 3, 4. Yeah, I have to create an array of size 4, and then I have to copy elements 5, 7. I have to ignore 8, copy 9 and 10. This is what the process might look like. So you can see this is a quite extensive process, right? It's actually an extensive process, requires maybe 2 to 3 steps. But what about linked lists? Notice carefully, what I'll do here is I can say that, hey, I want to get rid of this. So what I can say, this 7's next pointer, maybe I can just simply point it to 9. Yeah, I can simply point it to 9. So notice the beauty of it. 8 simply got removed. I never got to create a new linked list and then copy 5, 7, skip 8 and then copy 9, 10. No, I never had to do that. See what happened here. See what happened here. I'll get rid of that quickly. But see what happened. So I am removing it in this format. I am saying that, hey, 7's next was at 8. So right now I'm saying 7's next, hey, point to 9. It's that simple. It's that simple. So right now what will happen if I get rid of that? So this is what the linked list will look like. And have I not deleted 8? Yes, I have. So again, this is one of the manipulations, right? Manipulations means adding a data or removing a data, correct? So I hope that kind of answers your question that, hey, when I will be able to use linked list, right? So we'll probably meet in the very next video with a little bit of code and some of the important operations which you need to know to get started with linked list. If you found the explanation helpful, please make sure to like the video and subscribe to the channel as well. Thank you.